In this video, I want to show an integration strategy where we multiply by the multiplicative identity element 1, which doesn't change the value of the integrand, but it changes what that integrand looks like, and maybe we can rewrite it in a form that we can actually integrate. For example, in this integration problem, at first, I'm not sure how to integrate it. I see a bunch of e to the x's, so I may think u substitution, where I could let e to the x be u, but a du would kick out an e to the x in the numerator position, which I don't have. So I can maybe play around with more u sub, but there is something else I kind of notice. I see a 1 in the numerator, and then a binomial in the denominator. And that reminds me of some inverse trig. So I'm just going to notice I've got a binomial in the denominator, which reminds me of inverse trig. Specifically, arc tangent. The derivative of arctangent is 1 over x squared plus 1. So you may not see it quite yet, but at least you see the 1 over something plus something. So I think what I want to do is take this integral and multiply by a form of 1. And I'm going to choose e to the x. If I do that, it's going to put an e to the x in the numerator. And then down below, e to the x times e to the x, we simply add those x's to get e to the 2x. And then e to the negative x times e to the x, we add negative x and a positive x. They will cancel to 0, and I'll have e to the 0, which will go to 1. All right, so let's just try this out. So again, distributing the e to the x in the denominator, e to the x times e to the x is e to the 2x. E to the negative x times e to the x is going to be e to the 0. I can do some simplification. Now, this is a power to power exponent rule from back in the day. If you have e to the 2x, you can rewrite that as e to the x being raised to the second power. E to the 0 simplifies to 1. And this is looking really pretty. If I let e to the x be u, then du is sitting there, and I have 1 over u squared plus 1. So I'm going to let u equal e to the x, then du equals e to the x dx. And we have e to the x dx in that numerator position. We have e to the x being squared. So I'm going to now substitute, rewrite all these x's in terms of u. All of that is du. Down below, I have u squared plus 1. All right, so again, just multiplied by a form of 1. It doesn't change the function. It just kind of changes what it looks like. And in this form, u substitution works nicely. And now I know what the integral of this is. This is arctangent of u. And u was e to the x. All right, I'll see you in the next video.